I'm just trying to let this thing load and make sure we are rocking and rolling. I'm just kind of filling the air. I think I can go ahead and start the announcements. I think it's recording the audio pretty well. Usually it is. Um, and let me pull it up here. I think that's it. That should be it. Oh, it looks like it's doing it anyway. And make sure we are rocking and rolling. Cool beans. I'm just kind of feeling the Oh man, the smooth, sultry sounds of Professor Pfeiffer. My voice. It's always funny, like seeing and hearing myself. Okay. Let's see. We're gonna hop here, hit done, and let's share the screen. Okay. Start the broadcast. All right, we're gonna start off here. Let's suppress that. Okay. All right, so welcome, gentlemen. Welcome, YouTube fam. Let me see. Beautiful mind here. So we are in the home stretch with this group, with College Algebra. We only have 2 full sessions left. We got today and we got this upcoming Wednesday because we don't meet on Mondays, right? The last day of class is officially next Wednesday. And basically, my intent is to host the final exam the way I did last semester, where like in the past, but when we were meeting in person, there was like this common final. So last semester, basically, I just made it available online to my students. So it was just like any other exam. It was just cumulative, right? Let me see. So with this morning, sorry for the delay. It was totally my fault. It took me a while to realize, I was logged in on time. I'm sitting there. I was like, where is everybody? And I'm up here fuming, like, yo, where's everybody? What are they doing? Absent. And then I logged out, and for some reason I logged back in because I was going to do a quick live stream. And then I realized somehow I accidentally hit the use personal meeting ID. So I was logged into like a whole separate account, unbeknownst to me. That's how I came in right at the 10:15. I was like, oh, I clicked the wrong button and it put me into a different account. So we rectified it. You guys waited. I made sure you got your attendance. So if you're in the Zoom, and if you know somebody that was here who left, just have them log in before we end class today, and that way they can get their credit and everything can be copacetic. So again, I'm under the impression that next Wednesday is the last day of class, right? So we have today and we have next Wednesday. I did get an email from a student that asked about their grade. So that's the live video that I was about to create. So since we're here now, let me go ahead and do this because I feel like this can help the most people. If you're trying to get a sense of your grade in preparation for the final and your final grade and trying to make decisions and things, I'm going to basically use the following formula to calculate grades, right? So I want to say until May 1st at 11:59 p.m., you can access all old assignments. That means old exams, old quizzes, old homeworks, right? You can earn up to 90% on any assignment up until May 1st. That's huge. You can get an A minus on any assignment, right? So the formula that I'm going to do to calculate your final grades for College Algebra 2, basically the exams are 20%, and then the homework is 10%, and the quizzes are 10%, right? Total, right? So basically I'm going to take your exam 1 score, and I'm going to say times 0.2, right? Because it's 20%. Then I'm going to say plus whatever your exam 2 score is, your highest score, again, times 0.2, plus your exam 3 score, your highest score, times, let's be consistent with our notation, times 0.2, right? Let me see, exams 1, 2, and 3, and then plus whatever your average, whatever your homework average is. Whatever's on Pearson for your homework average, I'm going to take that and say times 0.1. A little bit more consistent, all right? And then plus whatever your quiz average is on Pearson, I'm just going to take that score and say times 0.1, all right? So this is 20, 40, 60, 80%, right? So then the final 20, so we're going to say plus whatever your final exam score times 20%. I think that's the grading rationale for College Algebra 2. And basically, I'm going to use this formula just like you see it. I'm going to take, again, for the exams, I'm going to take your highest scores, put them right there. Your average that's on Pearson for your homework, I'm going to put it there. Your average on your quiz, I'm going to put it here, right? So if you're trying to get a sense of what do you need to score on the final to get whatever grade you want, you can take whatever scores you have right now and plug them in. Hopefully you guys can hear me. With the setup I have today, I'm not going to be able to hear you if you unmute yourself. So you're going to have to use the chat. I'm using a wired connection. Can you guys hear me? Ali Oxenfree? Uh-oh. I don't think you guys can hear me. Let me switch this around. Testing, testing. No. I heard myself earlier. Let me see. Okay, yeah. I think we're okay. Because I checked my video and I can hear it in the video. Okay. But yeah, so I'm using a wired connection. I think it creates a better audio with less like downtime. I noticed with the AirPods, the audio will kind of come in and out. But with this wired connection, it's a little adapter I got. At least, and I have a microphone, so I was like, okay, I won't be able to hear you, but it's okay. So yeah, if you're trying to get a sense of what do you need to score in the final to get whatever grade you want, take whatever scores you have, you plug them in, right? And then you just play with different scores on the final, right? So like plug in what you have, and then you could for the final you could put something like suppose you get 80 on the final, then that'll spit out your score. Suppose you get 70 on the final, that'll spit out your scores. Suppose you get a 90, right? So you just plug in the scores that you have, and then you try different scores for the final. And that's how you can get a sense of what you need to score and what position. Idealistically, you want to create as much of a cushion as possible. So to do that, you want to maximize these scores. Even at this moment, right now in time, you can still earn up to 90% on all of these. Honestly, you can earn up to 90. These are the homework and quizzes, especially the homework, is a lot of work, right? So I don't want you to stress too much about that. That's a lot of work for a little bit of points. Whereas the exams altogether, this is 60% of your grade right here for 3 assignments. So you want to do your best to go through these and maximize those, okay? So again, today, if you have questions, comments, or concern, I'm going to have to, direct point you to the chat, put it in the chat, and I'll just check the chat periodically. It's not the fastest back and forth, but it'll create the best audio quality. At least I think it will. So I guess that was a confirmation from the pup. Go lay down. Don't tell me no. Just go lay down. Go lay down. You was doing good. You were fine. You weren't creating a distraction or anything. Go lay down. Lay down. Come on, hurry up. Go lay down. Lay down. Go to bed. Go to bed. Okay. Okay, sorry about that. She's like distracted. I'm trying to get her to lay back down. But she was asleep, but then she heard something, so she creates a huge distraction. So we only got about like 25 minutes left because of like the delay. I do intend to log on around 2:00 again to meet with that class, but it just depends on, the attendance or whatever. Let me check Zoom one more time. The chat looks clear. I don't think I have anybody in the waiting room. So with that, let's take the time that we have and get through as many questions from exam 2, right? So today we can go through exam 2, as many questions as we can. And then on next Wednesday, that'll be our last session. We'll get through as many questions from exam 3. And so basically your final is going to be cumulative. So everything from the beginning to the end, including that supplemental section can pop up, right? And just this is the best time to ask questions, during class. Okay. I'm not opposed to logging in during the final exam week for some periods of time. Just email me. I know I'm not the best with responding to emails, but like if you want to meet, just let me know. We can try to set something up. We can try. Okay, so this one we're asked to graph the function, right? So we have an exponential function. So normally, that'd be nice if I can draw here. Normally an exponential function looks like A, right? That's the general shape of an exponential. It kind of starts off flat running along the x-axis and then it takes off, right? But that's when the base is larger than 1, right? In this case, the base is between 0 and 1. So instead of exponential growth, we're going to have exponential decay, right? So that should be D. So we're going to submit D, and we're going to go with that one, and we're going to go into the next one. Match the graph to one of the following functions. Okay, so it just looks like a regular exponential function. But this is y equals 0, right? So it hasn't been moved up or down, nor has it been moved left or right. So for this one, it should be A, right? I can't see any other manipulations. It doesn't look like it's moved left or right or up and down or anything like that. So I'm just going to go with A. Okay. Let's go with that, and let's go into the next one. Find the simple interest for the value of the principal P, rate R per year, and time T. Okay. So the simple interest, right? So hopefully you have a formula sheet where you've been collecting formulas. The formula here for simple interest is I equals PRT, right? So the principal times the rate times the time. The only things with these units, the rate has to be expressed as a decimal, so we have to convert that one, and time has to be in the units of years, so we need to convert that one as well. So because we need to do those conversions, I'm going to take some notes. So let me start by getting a copy of this guy. So like here, here, okay. Then we're going to take that and drop it right here. Boom. And yeah, there should be enough space. All right. Before I get started on this one, let me check the chat one more time. Check Zoom. Check on you guys. Looks good, looks clear. Let's keep it moving. Right here. Okay. So again, hopefully you have a formula sheet. It's a good idea to just keep that up to date. And as long as you're neat and organized, you can find it quickly, then you can use it. So simple interest, we're going to do it like this. I equals PRT, right? So then for this one, the simple interest is going to be your principal, which is the 7,800. The rate as a decimal. So 3/4 is what? 0.75. So 5.75%. You can look at that percent symbol as per 100, right? So that means basically divide by 100. So you move the decimal to the left twice. So 0.0575. Okay, so that's the rate as a decimal. And then in time of years, let's convert that 9 months to years. We already got the 15 years, but we need to convert that 9 months, right? So if we have 9 months, we're going to put it over 1. We want to convert it to years. So we're going to say times, it's what, 12 months in a year? So 12 months correlates to 1 year, right? So the way I set this up, because months was on top, when I do my conversion, months need to be on bottom. So that way those units cancel out and we're left with the desired units that we want, right? So then basically we just say 9 divided by 12. What's that? 3/4, so 0.75. So then 15, so that's going to be 15.75 years, right? And then at this point, we just multiply. We don't die, we multiply like baby's kids. All right. A little bit of showing my age. I'm pretty sure most of you guys don't know that. It shouldn't, but you know. Let's see. Hey Siri, what's 7,800 times 0.0575 times 15.75?
7,800 times 0.0575 times 15.75 is 7,063.875.
7,063.875. We got to fix this. So 7,063 like this, 0.875. How much interest? Let me see. 7,800. Oh, for 15 years. Okay, yeah. I was like, why is the interest so high? That's a lot of interest. But it's because it's been running for almost 16 years, right? So $7,000 in interest over 16 years. Okay, so we got 7063.875. So let's hop back here to 2 decimal places. I think we said 7063 point, we said 875. So then that rounds to 0.88. Okay. Let's go for another 10 minutes and then we'll check and see how we did. Hopefully, you know, we just gonna have to go with it for now. Find the principal P that would generate the future value. Okay. Let's take some notes here. All right. So like this, like this. Yeah, because like you guys actually have been doing fairly well, like really well, at least as far as attendance is concerned. So that's why I was like, wait a minute, where are you guys? What happened? I was like that it was a holiday and when I did the presentation anyway, but it's okay. Okay, so future value compounded daily, right? So this is an example on compound interest, right? So we're going to use A equals P times 1 plus R over N to the power of NT. I don't really expect you to know this formula. I just expect you to know when and how to call on it and then how to use it. Compounded daily, all right? So let's plug in what we have. Let's plug in the different components. We're asked to find P, right? So we want to solve for P. A future value A, so it says that A is $10,000. That's what we want to finish with. 6% compounded daily. So that means our rate, if it's 6%, that means the rate is 0.06. If it's compounded daily, that means our N is 365. And that means if it's 9 years, that means our time is 9 years. Okay. So we're going to solve for P. Fortunately, we're solving for P. So we're just going to have, once we plug everything in, it's just going to be some number times P equals some other number. So in order to solve for P, we're just going to say A divided by whatever this number is. So again, once we plug everything in to solve for P, it's just going to be A divided by whatever this number is. Okay, so let's do it. So then we want to finish with $10,000. We're solving for P, 1 plus the rate, which is 0.06 divided by 365 to the power of 365 times 9, right? I think for this one, let's go like this. Let's do a new one. Let's break this one off. Like right there. We can suppress it now. Come on. Okay, let's see. Yeah, there we go. That's the good stuff. Reload and refresh. That looks good. Okay. So then, long story short, it's going to be 10,000 divided by that number. So we're going to say 10, 1, 2, 3 divided by. I'm going to use my parentheses. I'm going to do double parentheses. So we're going to have 1 plus 0.06 divided by 365. So, you know, it does take practice to use your parentheses properly here, to the power of 365 times 9. And then this closes off the denominator. So I use my double parentheses so that way I can capture the whole denominator by itself. And then, so how much do we need to start with? So if we want this, if this is an account where we're making a deposit and it's going to grow to $10,000 over 9 years with this rate, we should anticipate a number less than 10,000. So this is saying about $5,827.74 approximately. Okay. That's a reasonable answer. So we got 5827 point, and we're rounding to 2 decimal places because we're doing money like that. So if we start with this amount, you know, where the interest is 6% and is compounded daily for 9 years, you'll finish with 10,000, right? Man, I wish I had an account that was like a low risk that had this kind of rate, man. I would be all over it. I would be all over it. For you to use compound interest. Now, some of the things, now I'm no financial guru, is definitely something to look into. But, you know, on YouTube is a great place to start at least. This whole thing about dividend stocks. Like, basically, these are companies that just pay you to have shares in their company. So I'm probably going to start doing that. And I was doing it for a while where you just, you know, like basically every time you get some money, you put some of it into their company. And like periodically they'll just send you checks. It's like basically it's a return on like the profits earned or something like that. Again, I'm no financial guru. You definitely want to do your own research. I'm just a lowly math professor who intends to, you know, free myself financially and as many people as I can, but I'm not there yet. Let's 58, 27, 74, 58, 27, 74. There it is right there. That's the spinner. Okay. 2 decimal places. We got 5827.74. 5827.74. All right, we're going to go with that. Let's try to get one more in. I see the time. We're kind of short on time. Okay, let's just try one more. Starting with the graph of E, use transformations to sketch the graph of the function and state the horizontal asymptote. Let me see. Use the graphing tool. Okay. So the transformations here, right? We got this negative E to the power of X minus 5 plus 2. So the parent function or the base function is E to the power of X. So that's an exponential graph, which means that the parent function, without any manipulations, is going to start off flat, running along the x-axis, pass through the point 0, 1, and then grow exponentially, right? So then to identify the transformations, my recommendation is to work your way from the inside to the out, right? So the innermost transformation in this case will be that negative 5, where we're subtracting 5 on the inside. So that's going to cause a horizontal change. It should shift it to the right by 1. Multiplying the outside by a negative should cause it to flip vertically, and then adding 2 should cause it to go up by 2, right? So that's a whole discussion on transformations. So let's see if we can capture this one. Exponential is this third row left, so we're going to click there, and I'm just clicking anywhere on the graph. So again, we said we went right to the by 5, so we're going to slide it to the right by 5. The base is E. We said we flipped it vertically over the x-axis, so we're going to click that. That's not everything. And then we said we went up by 2. Okay. So then I think that's everything. Right? Mm-hmm. The outside causes a vertical change. So typically inside manipulations cause horizontal changes. Outside manipulations cause vertical changes. I'm going to go with this. What's the horizontal asymptote? Let me see. Y equals 2. Okay. I think I'm going to go ahead and submit the test. Kind of want to do another one, but we got through what, 5 questions? That seems to be about our rhythm. Once we kind of get going, 1, 2, 3, 4, 5, yay! So the ones that we did, we got them right. So I can sleep easy, I can rest easy. Let me check Zoom one more time really quickly. Yeah, thank you guys for showing up. Again, that was totally my fault. You heard the whole story. So if there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Okay, guys, take care. Good luck. Just ask for help. If you need help, you got to ask. A closed mouth don't get fed. Okay, guys. Enjoy your weekend, and I will see you all next Wednesday, all right, for our final broadcast. Take care.